All right, hello everyone. Today we're going to build an optimized portfolio using the modern portfolio theory. But instead of using a specialized like finance library, we're going to build it from the ground up using SciPy, fundamental scientific like computing library within Python. It's just kind of the specifics of it. So this approach really lets us kind of see the engine of the portfolio optimization. So we're going to define the math ourselves and then hand it to, the optimizer. And then, if you want an analogy, it's like instead of using like a pre-made cake mix, we kind of measure out the flour and sugar and kind of do everything ourselves. So the goal is the same though, to kind of find the best combination of stocks to maximize our return for like a given level of risk. So first, we'll take a look at cell one here. So this is the first one in our setup. So we're kind of importing the Y Finance, Pandas, NumPy, and all of these for the optimization engine to kind of get everything started. So after that, we just kind of like have our data. Nothing new. So let's kind of move on to the calculations portion. So in this step, we will kind of go ahead and calculate turn the raw price data into the two crucial inputs for our model, the annualized returns and the annualized covariance matrix. So first, we'll kind of plot the individual stock performance just to see what we're working with. And then we'll kind of get to the kind of results after we've gone through everything. And then we kind of go down to cell 3, and like we said, how our approach kind of differs here. We have to tell the SciPy optimizer to like exactly what we want it to do. So we kind of define the few of the functions like we were saying earlier to kind of give it the startup. So the get portfolio performance, it's just kind of like a simple helper that takes in and weighs, calculates the portfolio's total return and risk. And then the neg Sharpe ratio function is an objective function. So it kind of finds the maximum Sharpe ratio. And we tell the optimizer to find the minimum of the negative Sharpe ratio. And it's kind of a classic optimization trick. And then lastly, we have the portfolio volatility, which is a second objective function. And it is just to find the minimum risk portfolio. We just kind of tell the optimizer to minimize this function. So then we also just kind of have to define the rules of the game for the optimizer. The bounds kind of stay that each stock its weight must be between 0 and 100%, like we have here. And just kind of saying the constraint says that all the weights must add up to be 1, like we have here. And then we'll kind of go back and look at the results. So cell 4 will be kind of our final visualization. So unlike a specialized library, SciPy doesn't have a one-click function to kind of plot the efficient, frontier. We kind of have to trace it ourselves. So we've got to set up a loop. So for a range of different target returns, we rerun the optimizer each time, kind of asking it, like for the specific target return, what is the absolute lowest risk that you can find. So by solving that problem kind of like over and over for different return levels, we get a series of points. Connecting those points kind of gives us the efficient frontier. So, and then finally, we'll kind of plot that frontier, and then our optimized portfolios and our simple equal weight benchmark will kind of be all on one chart. So we will kind of run everything, and we will see that in, I guess from cell 1, our data is kind of here. So we can see that we will then plot from this, we kind of plotted the individual stock performance just to see kind of what we're working with. So we and then we will see here with the individual stock performance that we kind of calculate the daily percentage change to get our daily returns. So we're kind of being able to see that, we find the average daily return, and we ended up multiplying that by 252, which is said that the typical number of trading days in a year, to kind of annualize that. And we'll do the same for the covariance, which measures how the stocks move together. So we just kind of have here each of our 3 measurements for the stocks on the ticker here, kind of seeing that the MSFT kind of projected to absolutely blow up, or I guess has in this current year, after a few years of being closer to the other two. And kind of here we have our 2 ingredients, the expected annual return for each stock and the annualized risk matrix, and we can kind of just feed those into our optimizer. And so we just kind of see that the prices, like I was saying here, and the MSFT was just kind of skyrocketing from what we have seen. So after our cell 3, we kind of have seen that the optimizer has solved the puzzles for the minimum variance portfolio. It found the weights that result in the lowest possible risk. And then for the maximum Sharpe, it found the weights that give us the best risk-adjusted return. So we kind of have the weights of each of the stocks, and it kind of varies within, you got 50% all the way down to 14, and then up to 34 in the middle. And then, like I said, with the maximum Sharpe ratio, kind of just showing the difference. I mean, you got all the way up to 76% down to 0%. And that just kind of goes back to the lowest and the highest risk. So this 0% risk is kind of what we're looking for when you want a successful stock. So with the last part, with the efficiency frontier, we show that on our graph. So we have our result. It's the same, powerful concept. The green line is the efficient frontier, the limit of what's, possible with these assets. So our 2 optimized portfolios lie directly on it, as they should, and our simple equal weight portfolio as well. And the blue dot is clearly suboptimal, and it's inside the curve, meaning you could be getting a higher return for the same risk, or taking less risk for the same return. And the chart kind of proves the value of our optimization process, even when built from scratch. So kind of overall, by defining our objectives and constraints manually and using SciPy's the minimum function, we successfully replicated the results of a specialized library. And this approach kind of gives you an incredible flexibility and a much deeper understanding of how portfolio organization, or optimization rather, actually works under the hood, per se. And it's a fantastic example of how fundamental tools in data science can be applied to solve complex financial problems. So all in all, that is all that I have for today, and thank you very much for watching.